class. We're now going to continue our discussion of climate change and talk about other possible causes of global warming. Are there other possible causes of global warming other than the burning of fossil fuel? Well, how about sunspots? Sunspots are sometimes suggested. This plot again shows the average annual temperature, that's the red at the top, the atmospheric levels of CO2 with the Keeling data, little squiggles over to the right, then data on sunspots at the bottom, sunspots being these large bursts in the output of energy from the sun. As you can see that when you average things, the sunspot intensity does not seem to track nearly as well with the average temperature as does the carbon dioxide level. Scientists, climatologists who study these causes and effects have estimated the relative drivers of global warming or global cooling. And among these drivers, the greenhouse gases, carbon dioxide in particular, and others that I'll mention in a minute, seem to be the largest drivers of an increase in global temperature. The other potential drivers, the sun's energy output, seems to be a minor effect. And another phenomena, aerosols from volcanic eruptions, volcanic venting, or aerosols and dust from urban pollution actually cause a cooling by scattering light so that the light does not reach the surface of the earth. These would tend to lead to cooling, but we don't necessarily want there to be more volcanic eruptions or more air pollution and dust particles, although that would lead to some cooling. So the point is that climatologists, and you've often heard that the vast majority, and sometimes they estimate 97, 98% of those people who are in this field and study these phenomena, believe that greenhouse gases, especially carbon dioxide, produced from the burning of fossil fuels, is the major driver for global temperature changes. But again, are there other factors that may influence the warming trend? So let's mention a few. One would be the release of methane hydrates on the ocean floor and from Arctic tundra. And I'll show you an image in the next slide. Methane actually is a more potent per molecule greenhouse gas. It absorbs infrared radiation even to a greater extent than carbon dioxide. And these methane hydrates are actually a frightening possibility because there appear to be more of these methane hydrates than perhaps we were aware of. And the potential for the release of these into the atmosphere is a very unknown factor as to how important that might be. Another possible factor is the loss of Arctic ice, which can reflect sunlight, so that as we have a loss of ice in the poles, the Arctic and Antarctic, this ice would have reflected the visible light, but if there is a melting of this ice, then more energy from the sun would warm the earth. Another potential factor is that the oceans may become saturated with carbon dioxide. We said in one of our slides that carbon dioxide can be dissolved into the oceans, forming carbonic acid, which actually acidifies the oceans. But if the oceans become saturated with carbon dioxide, this could lead to more greenhouse gases in the atmosphere. And it's a compounding phenomena because as the ocean's temperature increases, there is an outgassing of dissolved gases. You see this phenomena all the time if you have a bottle of carbonated soda, like a Coca-Cola. If you warm it up, the gases bubble out, so that as the ocean's temperature increases, it will actually dissolve less carbon dioxide, meaning that the carbon dioxide would be in the atmosphere, thus being a greenhouse gas. The next bullet says population growth. With more people on Earth, especially more people wanting to drive cars, think of China and India and their populations and how their economies are growing, there will be more of a demand on fossil fuel consumption. Deforestation also depletes the natural consumers of carbon dioxide, that is, trees. Increased smoke and dust particles may block sunlight. That would actually have a cooling effect. A transition to non-greenhouse gas emitting sources of energy, solar energy, wind energy, nuclear energy, would minimize the release of carbon dioxide into the atmosphere. So this is one of the important strategies to try to limit the increase in global temperature. And finally, what is hard to predict is whether or not warmer ocean waters and higher carbon dioxide levels will lead to greater growth of marine algae and phytoplankton, which could then consume the carbon dioxide. So the point is there are a number of additional factors, and it's always hard to estimate the relative impact of all of these. In addition to carbon dioxide, another important greenhouse gas is methane, which I've shown the little structure of methane. Very simple organic molecule. As I've said, it actually absorbs infrared radiation to a greater extent than does carbon dioxide. And let me share with you a couple of interesting aspects. First, in mid-July 2014, a mysterious hole in the permafrost in northern Russia was discovered by helicopter pilots who were flying over this area. I mean, no one lives in this area. It's too cold. And I show an image of this large hole in the earth. In the journal Nature, a very prominent scientific journal, they published a story featuring this finding and the idea that this hole was created by an explosion under the earth, releasing methane gas. Due to the size of this hole, it must have been a tremendous explosion and a tremendous amount of gas released. In addition to methane gas that might be trapped under the earth and might be released through explosions of this sort, methane gas can also seep from lakes and swamps, natural gas pipelines, deep sea vents, and livestock. You know what I'm talking about. And as I mentioned in a previous slide, there are what are called methane hydrates that lie on the ocean seabed next to the continental plates. One thought is that this methane may be a good source of energy, but also as the temperature of ocean water increases, there is a concern that there will be a melting of these methane hydrates and a release of the methane into the surrounding water and bubbling up into the atmosphere. So methane is a second greenhouse gas that we also must be aware of. And one final point that I have in this slide is that as much as 5% of the atmospheric carbon dioxide release is actually produced as a result of the processing of concrete. And I don't think we're slowing down our production of concrete. Okay, we'll pause now and have a quiz. And then when we come back, we'll talk a little bit more about climate change, in particular how it relates to society and to us. See you shortly.